You're listening to KNX In-Depth. We're sponsored by your Southern California BMW centers. Along with CharlesFeldman, I'm Chris Seaton.
A reminder that after news and traffic at the bottom of the hour, we're going to be talking about the passing of Don Rickles and also the Republican chairman of the House Intelligence Committee, Devin Nunes, stepping aside from the inquiry into Russia and our election. Right now, though, get ready for a bumpy ride. New scientific research out today says airplane turbulence is set to get far worse in the future. We're joined by the study's author, Dr. Paul Williams of the University of Reading in England. The study is one that I suspect a white-knuckle flyer is not going to welcome. What does it say?
Well, what we have found in this study is a 149% increase in the amount of severe turbulence on transatlantic flights coming our way over the next few decades, and that's because of changes to the jet stream caused by climate change.
So when you're talking about changes to the jet stream, let me back up a little bit for those who may not be aware of what the jet stream is. Just briefly describe what happens when you're flying up there going from, say, New York or Los Angeles to London or to the continent, and you're flying high above the Atlantic at altitude. What is the jet stream?
Well, the jet stream blows from west to east. Actually, it goes all the way around the world, so over the Atlantic, over Europe, Asia, the Pacific, North America, and then it kind of meets itself again at the other end. And it can blow at speeds of, well, up to 200 miles an hour on a good day. And of course, that gives a nice, welcome tailwind for your eastbound flight over to Europe, but a very unwelcome headwind on the journey back over to North America. So this is the reason why a flight over to Europe is typically about 1 hour shorter than the flight back over to the U.S. It's all because of the jet stream.
Now, these changes, you're not talking about something that might happen. You're saying that this has already happened.
Yeah, we already have evidence that the jet stream has speeded up. And the reason it's speeding up is that the carbon dioxide emissions that we humans are putting into the atmosphere, those emissions are not warming the atmosphere uniformly. There's a pattern to the warming, so the different parts of the atmosphere are warming by different amounts, and in particular at 30 to 40,000 feet, which is a typical cruising altitude. And what we find is that the tropical regions are warming much more rapidly than the polar regions, and what that means is that the north to south temperature difference across the North Atlantic is increasing, and it's that temperature difference that drives the jet stream. So that's why the jet stream is speeding up, and of course a stronger jet stream means stronger turbulence.
Now, we were talking about transatlantic flights, but as you pointed out, the jet stream does go all around the world. So would this be, would one anticipate much stronger turbulence as well at altitude, even on, say, here in the U.S. domestic flights?
That's a great question, and we've only crunched the numbers for those transatlantic flights so far, but we are working as a priority on the other flight routes, and my guess would be that, yes, we will see similar increases all around the world.
And Dr. Paul Williams of the University of Reading in England.
Now, in about 5 minutes when KNX In-Depth continues, the California Republican who heads the House Intelligence Committee stepping aside from the Russia investigation, what it means, and to add insult to insult, the passing of Don Rickles.